Hello and welcome to today's Australian Water School webinar on flood risk management. I'm your host, Cray Price, and I'm thrilled to be able to introduce you to some experts in the field today who I'm sure will help shed some light for you on a very relevant topic that seems to be increasing in importance all around the world as we deal with climate change, development, and other challenges in this space. Today's webinar is gratefully and jointly sponsored by Synergy and WMS, and you'll hear a little bit more about them later on. But let's talk about you. We've had a tremendous response. If you look at this map of attendees, well over 1,000 registrants from all around the world. So welcome to each of you attending live today, and also to all of those who will be joining us on the YouTube channel later on. Now, let's introduce you to today's expert presenters. Catherine, Adam, if you want to turn on your cameras, maybe just let us know where you're joining us from today and tell us what you do in a typical workday. Let's start with Adam.
Welcome all. Adam Berry. I run my own flood risk management consultancy. I'm based out of the lovely Sunshine Coast in Queensland, Australia. Our consultancy focuses on flood modelling, flood risk management, disaster management, and a lot of community awareness projects. I myself am a very passionate flood risk management professional in the industry. I've been around for long enough now, and it's really exciting to see this industry grow and this particular subject get a lot of interest because it's something I'm very passionate about. So I'm keen to chat through the presentation, and also afterwards if anyone's up for a chat later, because there's a lot of detail to get through, and Kath and I can't get through it all, unfortunately. So keen to keep talking to everyone.
Excellent. Well, great to meet you. Catherine, and let us know where you're coming to us from today.
I'm coming to you from Sydney, Australia, in New South Wales. It's nice and chilly here this morning, but a sunny blue sky for a change. I'm a director at WMS Engineering and have been in floodplain risk management for about 12 years now, focusing on translating outputs from my flood modelling team to the broader real-life application with councils and communities, and I suppose using flood modelling tools to get floodplain risk management projects up and running. I'm also the current communications director with Floodplain Management Australia, so that translating technical information to not or less technical audiences is sort of my jam. So I'm really excited to see so many people also show an interest in that this morning, and I hope we can teach you something new.
Great. Well, thanks for those introductions. Now, thanks to everybody who filled out the poll results. Let's pop those up real quick and see if there's any surprises in terms of, where people are coming from. The main challenge here, and maybe to each of you, I'll have Catherine answer the first one and Adam the second one there on, question number 2. Catherine, is that what you expected to see? Is that the main challenge that you expected to see from the participants today?
I'm just trying to find
it. Says the lack of the biggest one being the lack of understanding or poor access to information. Would you have expected that one to top the list?
Poor access to information about flood risk, I think, is a big one. I guess internationally, I can speak from Australia's where we're doing well, but we can do a lot better. And I'd imagine internationally, there's a lot of challenges to getting good, and like Kath was saying before, good. We need technical information, but we need to simplify it for the communities as well. So I think that's a real challenge worldwide. So I don't think that's a big surprise, that one at all, Craig.
Excellent. And then it's pretty evenly split there in terms of what describes the areas that people are coming to us from, and it's pretty evenly split. So we've got a little mix of everything. Catherine, any further comments before we dive into the presentation?
I was surprised it's such an even split. I suppose in the Australian context, so much of our population is on that east coast with riverine, like smaller creeks and flash flooding risk and major overland flow in urban areas. So it's great to see a broad range, and we're going to be covering flood risk that, can span all of those settings. All of the stuff we talk about today will be transferable across all those contexts. So, that's really good.
Adam, I think Adam's going to be leading the presentation with with the PowerPoint, and then Catherine will be kind of tag teaming back and forth.
All right. As Craig said, we're going to flip a bit between us to make it a bit interesting and have different perspectives on things. First of all, a very big thank you to AWS for having us, and a big welcome from Kath and myself. We are truly honoured to be able to deliver something that we're passionate about, which is flood risk management. But I guess, as Craig mentioned, we do have quite a lot to cover, so we're going to get straight into it because we have a short time to ram a lot in, which is what we're aiming to do. Natural hazards are something that can occur all the time, and generally they're at minimal risk where human settlement hasn't occurred. It's only when we bring that human interaction and built infrastructure into the floodplain that it actually presents a flood risk to our community. So we have to remember that we're the ones that have always introduced that flood risk to ourselves. Hazards can occur generally and have no impact. It's only when we're involved with them that they actually occur. When we first start our flood risk journey, we tend to start with an international perspective. So we tend to use an ISO 31000 standard, and then we generally adapt it to flood risk to be relevant, and it could be locally relevant as well. A journey with flood risk starts with the basics of a combination of likelihood and consequence, and that being the likelihood of the flooding occurring to the community and the consequences that occurs as a result of that flood event. And translating that into flood talk, we're basically talking about flood frequency expressed in annual exceedance probability, which I hope everyone's sort of familiar with a little bit, and then the hazard that occurs with that. So generally a combination of depth and velocity. And it should be noted that this is just our first starting point for flood risk. There's a lot of flood risk elements that incorporate holistic flood risk, and we'll talk about those a little bit later.
Yeah, so to structure today's presentation, we've decided to kind of base it on the old Crichton risk triangle, which includes the sides with hazard, so like the physical, actual characteristics of that flood behaviour, exposure, so what is actually at risk, buildings and people, and the vulnerability of those buildings and people to damage and loss. And those three sides come together and make that risk. So as Adam said, you can have hazardous flooding, but if there's no one being impacted by it, you can have a very, very low or minimal risk. Just a quick kind of disclaimer before we get into this, though, is that we've got a side here that says vulnerability. And this triangle was come up with in about 1999. So we have a slightly different understanding today of vulnerability and what that encompasses. So I'll just let Adam kind of draw some of those things out before we take it too much further.
Yeah, good point, Kath. So yeah, the word vulnerability sort of morphed through the decades, I guess. And it's really important to note that before we even start to jump into flood risk hazards and frequencies and isolation risks and all those sorts of things, we have to recognize that already in communities that we have vulnerability, a social vulnerability throughout our communities. And more often than not, that these vulnerable people are located in areas of high risk. So before we even have a flood come, we've already got risks associated with our social vulnerability. So we really need to be cognizant of that before we start to apply our flood risk factors over the top of that. And just sort of really quickly summarizing some of those vulnerabilities, we can have physical vulnerability. Examples are the age of the population, the elderly, the young. You could have elderly living alone and need assistance in everyday living. We've got economic vulnerabilities such as lower socioeconomic conditions, lower household incomes that amplifies their ability to not respond in flooding. We can have mobility issues whereby households have a large number of people in the house or a lot of children, and they may have no cars or one car, and it makes it really hard to move within a flood. And the last one is a really important one as well, as the awareness factors and the vulnerabilities associated with that. And that could be just generally new people in the area, or just having a lesser understanding of the surroundings or the previous flood risk in that community. And depending on what the native language is, non-English speaking or whichever, that makes it really hard to communicate with people as well. So you factor all those things in before a flood comes. It can add and compound to the flood risk.
We've included this slide to kind of demonstrate that you can't really apply a one-size-fits-all approach to flood risk. and it can't really just be simplified into the frequency anymore. So this is showing the same. So all of these houses would be built with a floor level to the 1 in 100 year event level, potentially plus some freeboard if you're doing it well. But you can see just how much a flood that's twice as rare. So from going to it from a 1 in 500 to 1 in 100 to 1 in 500 event can look markedly different depending on the catchment characteristics and the topography. So, yeah, I just thought that was an interesting slide to throw in about that comparison of flood risks and how in different settings the likelihood can really convey a different level of impact to houses. Which kind of goes into the next one.
So as I was sort of saying at the start, there's multiple factors with flood risk, and traditionally, as we've morphed through our journey in flood risk, we've generally just started with the flood extent or using one flood event to define our flood risk. So the 1% AEP or annual exceedance probability is a fairly common one, but it could be less in other countries. And we basically started to use that, and that was it. We defined our risk, we put our extent on a map, and that was it. Recently, we've started to use more flood events, a different range of design events through our assessments, and also using hazard that started mixed in, and we sort of turned this flood risk-based planning approach from that. But that's just the start of the flood risk journey. It really is only the basics. I guess for some countries it might be more, but I guess for Australia and maybe other countries, we have sort of moved past that, or at least trying to make an effort to. And there's many other elements of flood risk that can multiply our risk. And Kath was saying before, it could be the type of flooding, whether it's flash flooding, how quickly that flooding occurs. It has obvious implications on people's response times and ability to respond to flooding. The duration of flooding and how long that flood lasts and how long it inundates properties and how long people can't get to emergency services and also essential services. Our amenity of culverts and bridges makes it difficult to move around. Isolation risks where people get trapped on islands. And I guess there's a big range of factors that sort of multiply our risk, and we really need to get a better understanding of each of those elements on that graph there to actually know how to treat that risk, to properly understand that risk and how to do it. I guess as an example, you could have an isolated community that gets isolated very quickly with really low humidity roads. They end up on what's called a low flood island. And if that water keeps rising and those properties inundate, that's where you generally end up with people on roofs and having to be, rescued by boat or helicopter. And it's very hazardous, life-threatening sort of flooding. So to get a better understanding of that through the flood risk journey and those really high-risk areas is a really important factor of how we look at flood risk. And it's important to get those things better down before we move into, Kath's going to talk about some management measures, before we move into those management measures, to just bed down those really important areas that are hard to identify with just a line on a map, I guess, a map, which is really important. I just thought we might try and make this a little bit graphical because we did talk to a lot of text and PowerPoints a lot of the time. So this is just sort of showing what you can do undisclosed location. Some people might recognize it. As I was saying before, just tick on off these layers really quickly. This is just identifying that community vulnerability we were talking about. Obviously, behind these layers sits a lot of data it's really powerful that Kath and I would use in a project, for example, to really hone down our flood risk and understand it a bit more. We can combine this is just a map showing combined likelihood and hazard, and it's sort of just, it's from everywhere from the 50% AEP all the way up to the PMF. So just a different way of displaying things. As I was saying before, we can also map how quickly a flood comes through. So if I sort of click anywhere on one of these grid cells, it'll come up with a rough time of how quickly that flood will arrive and how much time you have, how much warning time. We can also map how long a flood lasts. So as it moves through the system, you can sort of see it's more purple down the end. So the flood's going to last a lot longer down the bottom. Apologies, I'm really quickly flipping through this. We can map flood damages across the floodplain, get an understanding of those pockets of where those damages occur more frequently. This is a personal favourite of mine, I'm sure Cass as well. We can map road immunity across the entire LGA, country, whatever it is, and it gives you a really good understanding. The black and the red is basically where all the roads have really low flood immunity, so it gives you a really good understanding of how you can move around the city and where your hotspot areas are for evacuation and infrastructure upgrades, things like that. Mapping flood islands as well. So these are low-end flood islands, as we were talking about before, where people can become isolated. So you can map these across really big areas. They're really useful, powerful tools. And then you can take things even further and then sort of map to evacuation centers. So the green being where people can access evacuation centers and the red being where they're isolated and can't access that. So that's just a really, really quick screen share of that. And I'll go back to our PowerPoint, hopefully. I think it's that one.
Yep, you can see that just fine. I go full screen.
Yes, beta.
There we go. Perfect.
Back to you, Kath. That worked.
Nice one. Yeah, good stuff. So we're going to get into a bit more about floodplain risk management now. So I thought we'd start by saying what floodplain risk management is not. And using this triangle format, again, it's not about eliminating any one side of the triangle. It's you can click through and we'll cross these out. So it's not about removing the hazard completely by stopping floods from occurring. So it's not about building levees everywhere to stop the river actually impacting on a town. It's not about removing the exposure either by having zero development or just prohibiting use of the floodplain altogether. That would really sterilize a lot of land in most of our countries that we're all coming from today. And it's just not feasible. And it's not about removing vulnerability altogether by protecting every single person in every single building up to the PMF in every single location. I don't know about you, but I quite like having some soft furnishings in my house. And I think we need to, strike a balance between having things that, they could be damaged by a flood, but managing that risk appropriately. We've thrown in there too, it's not about relying on like stormwater infrastructure or things that are generally designed for smaller rainfall events like rain gardens or on-site development to manage large overland flows. And it's not about relying on the local government or the federal government to reduce flood risk holistically. It's, I don't know, I've come across communities where there's a sense that there's a duty of care of the local government to prevent overland flow. And that's just not the case. They didn't put the flow there, but we've got to work with it to keep buildings and people safe. Do you want to just fly through these next couple, please, Adam? So if we can't eliminate any of these sides, we can shrink them. And what we want to try and do is reduce that overall size of the risk triangle. So if we can shrink the hazard, we could shrink the exposure side. Go to the next one. We can do things to reduce the exposure and how many properties or people we have in floodplains. And we can take actions to reduce the vulnerability of the buildings and community within the floodplains as well. So we're just going to go through each of those reductions and how we can do that through our floodplain risk management processes. So we're starting with Adam for this one. And jump in.
As Kath mentioned, so we sort of very quickly established those slides with how you establish flood risk. It is obviously a very detailed process to get to there. But now I want to sort of look at one of our methods, I guess, of reducing hazard, and there are multiple methods that we'll go through. But I guess one of the first things that people sort of point to straight away, as Kath said, and I don't necessarily agree with it. I think we really need to take a holistic approach to, as Kath said, with the triangles. There's multiple things we can do to reduce our flood risk. And it isn't always by reducing the hazard and physically putting in infrastructure to reduce that flood risk. That is one important element of it, obviously. So there's obviously, most people will be quite aware of the different structural flood mitigation interventions that we can do. Here's just a few. We won't go into these in detail because Kat will actually be doing a follow-up course with this that goes into detail of structural mitigation. But the fairly familiar ones are flood levees, bypass channels, dredging of creeks and rivers, which I don't recommend because it's terrible for the environment, dams and detention basins, pipe upgrades, floodgates and backflow prevention devices. I just put up a shot of that levee because that was one I was involved with 15, 20 years ago. And I learned a lot off that in my journey in flood risk management, in that, like I was saying, you need to be very careful with just blindly using structural mitigation as a tool to encompass all of flood risk. Because there is lots of things to consider. I'm going to say some of the negatives. There are a lot of positives. Some of the negatives are around, they're often not feasible. They're often not cost beneficial. And one of the really important things is the residual risk that remains from a structural option can actually elevate your risk in particularly higher magnitude events. And I guess one thing that I'd focus on is levees in particular. And there's a term called levee paradox, and basically it's a situation where a structure is intended to protect against floods, but inadvertently it can cause an increase in flood risk, particularly in higher magnitude events, because what it does, it creates a false sense of security and a reluctance to actually understand flood risk in general. You sort of hide behind the levee, everything will be okay. And as a result, there's worldwide examples across the world of where this has happened. It does cause significant delays in evacuation because basically everyone waits to evacuate until the levee's breached, and by then it's too late. There's a heap of other flood risk factors that come in play. Evacuation routes are already flooded. It creates a really life-threatening situation. And probably the best example I could give in the world, and again, I'm not an expert on this, but is New Orleans, and everyone's quite familiar, I think, with that. The levee actually breached in 50 different locations. It was a sudden cause in high velocity floodwaters, and it moved houses off foundations. And in that particular event, there was 1,464 people that perished. Obviously, that wasn't all related to the levee, but it was just an understanding. This is basically just to give people an understanding that if you are going to invest in structural mitigation, levees, dams, that there are a range of things that need to be considered. And I guess my advice for this is that when you're considering structural flood mitigation, is make sure you consider all of those flood risk factors, and also the other intervention measures which Kath is going to talk through as well. They all need to be considered as one holistic package, not just putting a levee or a dam in. And I'm not anti-structural mitigation. I'm just saying that we just need to consider things really thoroughly. I guess the message up there is we can't fight our way out of flooding all the time. We've tried to over history, and often that's failed. So we just need to consider the residual risk that's also left over.
Yeah. I think just while you're on the reducing hazard sides, we've got a lot of urban settings, or like people from urban settings on the line today. And I think you'll all know what constraints you're up against with space as well, and what the community would like to live next door to, and how expensive land is to actually acquire to have easements for things like this. So we know that we can't just rely on reducing the hazard with structural mitigation options. And even if we could, as Adam said, I really want to hammer this home, is that reducing one hazard can introduce a whole lot of other hazards. So if we're talking about urban retention basins that are designed to catch some runoff and then let it go at a lower peak flow, is that introducing some open standing water that children might want to come and play in, and they're at risk of being drawn into the outlet pipe? Do we need to consider fencing? If we're using schools and like playing fields to do this, what impact does that have on like all the sporting fixtures and that community value of that land as well?
Yeah, I was also going to add, so that's good cover. Cut off my slides if I didn't read it all, but one of the, and I know a lot of people are passionate about that. The environment's a big factor that we need to bring in as well, and always should consider. There's so many examples worldwide of just absolute decimation of the environment to do structural mitigation, and even just introducing dams and levees can have significant impacts with diversions and bed shear stress on our rivers and creeks. So we need to treat them as living things, the rivers, and we need to be cognizant of the environment when we're looking at this intervention. Sorry, Kath, back to you.
Yeah, no, I think we're all kind of saying the same thing. We're not anti-structural, but it's not necessarily the silver bullet that it was maybe once considered to be. So we kind of couple that approach with reducing the other sides of the triangle. That will give us a much more holistic and sustainable way to manage flood risk in our communities. So I think moving on to reducing the exposure. So this is where we're talking about land use planning, what zonings we apply to different areas within our floodplains and outside of our floodplains, where we develop, how many properties we are putting at different areas, and what types of properties we're putting or types of development we're using different areas of the floodplain for. So this, again, it's not about sterilizing the whole floodplain. That's just impossible in most of our floodplain contexts. We need to use that land, and it's nice land to live in because of the amenity of the local river system or the creek system. But there's different, I suppose, within the floodplain, there are areas that are at greater risk and have greater hazard associated with them that make sense to have less critical or sensitive uses applied. So that's why you might commonly see if there's a river through a town or a creek, it's surrounded by recreational parks and open spaces to allow that water to spill out without impacting anyone. Then the next layer might be commercial or industrial, where you don't actually have people sleeping overnight closer to the riverbanks, and residential developments further uphill away from that hazard. So if we go through, I suppose with floodplain risk management, any project, we're looking at reducing the exposure of existing development. We've got a lot of legacy dwellings and properties in Australian context that potentially should not have been built there initially, or now that the catchment has developed over time and with climate change, maybe houses that previously weren't thought to be at risk now are. So Adam's got a couple of examples of things we can do at that property level, like specific measures to reduce exposure of individual dwellings.
So as we said before, structural mitigation generally is a community base. It's quite a large scale, but we can throttle that down to a lot scale or house scale, basically. And one of the ways that we can do that, or some of the ways that we can do that, are basically through voluntary. I think a long time ago there was compulsory land buybacks. I'm not sure it's much of a thing anymore internationally. It's more so voluntary buybacks. There's a lot of examples in America, a lot in Australia that we could reference as well. Big land swap things for Australia, the biggest and most known one was somewhere in the Lockyer Valley, where they moved basically the whole town up onto a hill. And then another one is house raising, so lifting houses out. I guess the reason we get into these situations is the decisions of the past have meant that these properties have been developed in high risk areas, and the aim of flood risk management moving forward, I guess, is to use better land use planning techniques to not have this problem in the future. So if you're in flood risk management land and you're doing future planning, what you don't want to end up with is having to purchase properties or raise properties in the future because of haven't thought forward about the flood risk in the future. You haven't captured it properly and understood it properly. So I guess by removing houses out of the floodplain and the large large land swaps as well, there's things that you do need to watch out for, because like Cass said, there's always an offset, there's always a negative. So if you individually buy one property and there's three that sit beside it, you've just got a vacant block there forever and a day. It doesn't sit well in the community. So you've got to plan those sorts of things really well. It's really important that when you do I know a lot of the projects that I work on, I'm sure the CAF does as well, but good prioritization of those particular properties and those groups of properties. You should be looking at multiple flood risk factors like hazards, frequencies, flood damages, lots of things to make sure it's prioritized properly as well. And I was just going to mention as well, one thing, so house raising examples are basically where you have a house and you lift the foundations up like this photo shows to get a few more meters of flood immunity. And that's great. That's fantastic. But the things you also need to be careful of is if there's an extra 3 or 4 meters of floodwater surrounding that house, they could be in quite a dire situation if they do need to evacuate, like similar to before, talking with the isolation risks, where you are essentially, by the time you decide to evacuate at that level, you can't move anywhere. So you will be stranded in your house. So you do need to make sure that you can safely shelter in place in that house as well. So when we're doing flood risk planning and management measures, all of those flood risk outputs and the understanding the risk is a really important element to decide which houses are appropriate to lift and raise or purchase or other things like that. So just, I guess my message there is to, again, it's like the levees. You just need to be wary of the residual risk that's left, and then using other elements of flood risk management to potentially manage that risk might also help.
Yeah, just while you're on that slide, we'll go into this in a lot more detail in the September training course. And we're going to sort of get into the detail of, I suppose, as engineers, sometimes it can be a bit simplistic to think, well, why don't we just move those houses out of the floodplain? And we've got to have, I suppose, a lens of like all the other infrastructure needs that those residents would want. If you relocate them and their neighbours, do we also need schools and shops and parking and all of those things that build a community in a town to actually make sure people feel comfortable to go to the new town? There's all sorts of equity issues with, well, are renters eligible for assistance to move up to a new place, or is it just for homeowners? Is it just for homeowners that have paid off their mortgage? Like, how is it actually going to be sort of rolled out realistically? And with house raising, you always get issues with, well, I'm going to renovate my house and, oh, yeah, council says I have to come up to a new flood planning level. Oh, look, my neighbour's just been subsidised to do the same bit of work on their house. So I did it at great expense to myself off my own bat, and this person's just had 2/3 of the cost covered by someone else. So, yeah, there's lots of social and, yeah, there's community metrics that make these really difficult to implement.
Yeah, I think
really,
the thing out of that, Kath, would be, I think you've nailed it, that there's a need for multiple professionals. Once we sort of get more into the detail, like as engineers, we can produce some really great data and information and intelligence for decision makers. But yeah, there's some big social aspects to all flood implementation of flood management projects. There's some big social implications. Over to you, Kath, on managing future risk.
yeah, well, this someone in the chat's already sort of asked about this. So this is all about the land use planning and strategic decision making that councils need to do before the housing stock gets there and is put at risk. So for this kind of topic, yeah, I suppose we're talking about taking modelled flood metrics and flood information and historic flood evidence to help manage and decide what risk should be avoided, what risk is tolerable, and what risk is acceptable. And there's no one-size-fits-all guidance I can give you on you shouldn't build it this year or this year or this year. There's lots of good, I suppose, industry guidance out there that you can draw on. But I ran some training yesterday with the Planning Institute of Australia, and it was deeply unsatisfying that we can't just prescribe, here's how you should map out your floodplain, here's how you should break it up. Even that, there's several different ways you can do that, using hazard or using flood planning constraint categories, which consider hazard and isolation factors. You can do it based on like floodway, flood storage, flood fringe, anything between the flood planning area and the FPA. I'll cover off that in the next slide. But yeah, this is basically the crux of that training course is that if you go through a process like a floodplain risk management process and have some good discussions around it, each sort of council or jurisdiction has to come up with what will work for them, for their land use requirements and for their community and their risk appetite and the hazard that comes with their flood risk. So if they've got major riverine flooding, they'll need one set of rules. If they've got major overland flow flooding, they'll have a different set of rules. If they're in a very steep flash floody escarpment, different set of rules again. So you can learn from neighbours with similar catchment characteristics, but at the end of the day, unfortunately, each jurisdiction needs to go through this process within their own context.
Yeah, I think in at least in the area that I'm in, the words avoided, tolerable, and acceptable, they vary across neighbouring councils. You could have a neighbouring council has a different understanding and definition and tolerance, I guess, of what they're going to accept in flood risk. So it was actually at the Floodplain Management Association meeting that someone mentioned, wouldn't it be great, like Cass just said then, to have one standard where, but in reality, the communities are different as well. So you could have a community out in Queensland, out west, that has a much higher tolerability generally for flooding. They are much more aware. They're much more resilient. They might accept flooding a little bit more than urbanized areas. So it does vary across communities as well, how much they are prepared to accept to be flooded as well, which is a really interesting discussion.
Yeah.
Try this one for you, Kath.
All right. So Adam's going to do some clicking because we're going to talk about how, so in New South Wales, we call it a flood planning area, but this can be applied to anyone. It's just defining the area within the floodplain where you want to apply development controls and actually get proposed developments thinking about their flood risk and making sure they're designed to be compatible with that flood risk. It's not about prohibiting development in this space. It's about where you're applying that extra level of consideration of flood risk. So say we've got a nice valley with a channel. Normally the creek's pretty low. Yeah. All right. So then we want to pick a flood event. We can call this a defined flood event. It could be a 1% AEP or annual exceedance probability. So a flood with a 1 in 100 or 1% chance each year of occurring. Someone called me out on the 1 in 100. You can still say 1 in 100 AEP. It's the same probability. We're trying to get away from the 1 in 100 year annual recurrence interval language in flood risk management, because you're right, people do associate that with, well, we've had one, so it'll be 100 years till we have another big flood, which is not the intent of that language at all. But yes, old habits die hard, don't they? So we're picking an event that we would like to protect property from. Now, when we model a 1% AEP event, there's a whole lot of uncertainty with what that level could be in reality. So we add a factor of safety called freeboard. That freeboard accounts for the precision of your data and your modeling capabilities. It allows some variation in water level from like local surge or a truck driving through the flood and splashing over here, or a culvert being blocked and it diverting water over here. Maybe some climate change allowance, although that's being treated quite separately soon in Australia with different guidelines. But freeboard has traditionally included some allowance for climate change. For flood planning levels, that's about it for the components of freeboard. If I was talking about a levee in this situation, you also include some freeboard to account for that levee settling over time. If it's an embankment, it might just drop down as the soil compacts, or defects from traffic going over that levee over time, or animals using it. So we don't need those sorts of components for freeboard for planning levels. But this is what sets, well, what we call in New South Wales is the flood planning level, but that's the minimum floor level generally that you want houses to be built to in a residential setting. It could be the minimum floodproofing level you require for a commercial setting. It's just, yeah, that's the level that we've decided the risk above that is tolerable, the risk below this is intolerable, and we want to protect against it. So traditionally, we would take that flood planning level and stretch it out to meet the surrounding terrain. And we'd call that a flood planning area, or we decide that within this area, we want to control development in relation to flooding. And then I think the last one might be one more click. In lots of valleys or lots of settings, the PMF would then be higher than the flood planning area. So this is sort of
For those who don't know, PMF is probable flood.
Yes, probable maximum flood, which is the least probable flood that will ever occur, that meteorologically could occur. Now, this obviously, I've got a few reasons why this is a kind of a deficient model. This doesn't work very well in catchments that are quite flat. So if you're adding 0.5 meter to a 1% AEP level in some, especially regional, very flat catchments or areas, adding 0.5 meter could push that extended mapped area out 10s, 20, many, many kilometers beyond the LGA extents, beyond the PMF extent, and it's just completely impractical. Even if it doesn't go that far, if it's going beyond the extent of the PMF, it's too far. It's not really adding any value to your planning considerations because it's just saying, well, everyone in the PMF now has to consider flooding. It also doesn't work particularly well in overland catchments with very steep terrain, where that water in a 1% event, it's still just going to rocket down the hill. It's that head-driven momentum with gravity is always drawing that water down the steep slope. It's not going to spread laterally onto other properties. So does it make sense to incorporate houses off to the side in that, to capture those for flood controls? Possibly not. So it's not a silver bullet. It doesn't suit every single context. But I thought I would provide some background for planners that have heard these terms and were wondering how they come about in relation to flood modelling. I think, we're kind of getting to the end. So the final triangle with the side that you can shrink is the vulnerability. I've got me down for that. So we're talking about reducing losses to properties and reducing how hard it hits people, essentially. So we might just touch on property first, Adam, if you like.
Yes, Cass, so we're down to kind of more of the softer things, and these traditionally have been things that I've seen over my career that haven't been considered up until recently. So there are many examples internationally encompassing retrofitting property. So basically retrofitting a house to make it more flood resilient when a flood comes. So in a way, welcoming flooding into that house is a term, I guess, to be used. And essentially the aim of this is to reduce the flood damages by the damages that occur as a result of flooding on panels, doors, walls, all that sort of thing. So for retrofitting those aspects of the house, so the walls, floors, doors, kitchen appliances, lifting power points, higher electrical power. And I guess a simple example would be that changing carpets in a house to tiles in a house or polished concrete can make a huge difference to your flood damages overall. And there's actually a colleague of mine, James Davison, who's quite a prevalent architect in this space. And there's real life examples of where residents are able to just come in with a hose and wash the house out, and they're back in the house within 2 days instead of months or even years in some cases, like we're seeing in New South Wales recently. So that in itself is a huge benefit. But I guess like all things, this also isn't a silver bullet. It needs to be used selectively with a good understanding of flood risk. As an example of that, and I have seen this, we shouldn't be aiming to make houses more flood resilient in very high flood risk zones. So if these houses are exposed to high hazards and things like that, it might make homeowners a bit more comfortable in their homes and stay in their homes where they shouldn't be. So again, we should be looking at prioritizing these locations that are suitable for, I guess, still being flooded, but not from a hazardous flood that has a risk to life and structural damage to houses and things like that. So we should look at all of our multiple flood risk elements like we talked about before and using those to prioritize these locations. And I guess the thing I'd end on with retrofitting houses, I've done a lot of flood risk management plans, and more often than not, these are the most cost-efficient way to reduce flood damages in floodplains. And some of the prioritizations I've done, again, I'm sure calculators as well, you're seeing like cost-benefit ratios of like 7 to 1, 10 to 1. So basically, by investing in flood resilient materials and houses, you're seeing a benefit of 7 times versus 1. So there's 7. I've just lost my terminology. There's the cost that would do to the cost to implement this. It's actually 7 times better off over time, and it repays itself back really quickly. So I'm really thrilled to see this is a really big program across Australia at the moment, in both Queensland and New South Wales. There's a lot of investment, actually, like billions of dollars that's gone into, retrofitting homes, removing homes from the floodplains, and they've been really successful programs over the years. And I think they're one that originally was discounted and not considered in flood risk management at all. And it's really nice to see it. And again, it just sort of exemplifies that we need to have a full mix, a full gamut of solutions to flooding, not just levees and dams and things like that come into the picture. But this is there's some really simple things you can do in houses by, like I said on there, just remove the ability to remove cabinetry really quickly using hardwood instead of soft timber. I've seen houses that have been flooded, and if they're made out of hardwood, that hardwood doesn't rot, it doesn't fail, it comes good over time, and there's a huge cost implication. There's also, from a sustainability point of view, when you see houses flooded with traditional materials, all of that goes to the landfill, basically. So there's huge amounts of waste that gets generated through floods. So these are example of where you can introduce a different method. But again, just being mindful that we really shouldn't be retrofitting for houses if they're in high hazard areas as well. That's just again, like I said before, not a silver bullet.
The other side of the coin with vulnerability is empowering people who live in floodplains to be more aware of their flood risk. There's plenty of research out there that shows that if you've got great awareness of the flood risk you're exposed to, you're more capable of preparing for it, responding to a flood like during the event, and also recovering afterwards. So part of what we do in our flood studies is try and incorporate the community throughout the process. So we've got some photos there of actually getting the community together to point out where their risk areas are around town, engaging with the local primary school students and giving them a bit more background behind why it's so dangerous to drive through floodwaters and what's happening to the road surface underneath and what's happening to cars and their tires and their engines. And I suppose piquing that interest from the scientific point of view, because it's quite difficult to convince grown-up drivers to change their habits, but hopefully the kids in the backseat can start having an impact, and when they get their Ps, they're not making the same choices. I don't know if this is the same internationally. I'd be keen to hear in the chat if it is, but the greatest reason of flood fatalities in Australia is motorists driving into floodwaters, and it's not always people being silly and reckless. It's people trying to get home or pick up their kids from school or daycare, or they don't feel like they've got the time to make a different choice in the moment, or they might not be able to tell that road is a dangerous road to cross. So coming up with some more education on that kind of stuff is a critical component. I feel like we've maybe rushed that side of the triangle slightly, because it is really critical to bring the community along for this journey of understanding their flood risk in a way that works for them in their busy lives and with the limited mental headspace people have for new information. But it's really important, so that community connectedness and actually, having some connection to the land you live on. I really see a difference in how well communities cope with floods, in those settings.
Couldn't agree more, Kath. And the softer side of flood risk management is what we don't do so well. And it's so effective. I've seen it firsthand, like Kath has, and it's inexpensive as well. Just go out and have a chat with the community. It doesn't cost a lot of money compared to building a $500 million dam or whatever it is. There's some really simple things that you can get going straight away without planning too much. I guess just get it moving, get out and talk to people, get them to understand their flood risk. It makes a huge difference. Part of another element that's sort of a branch off of flood risk management is a concept what we call total flood warning systems, at least in Australia anyway. And I guess I won't talk too much about this because it is actually an upcoming course. We'll talk about it a little bit more. But similar to flood risk management, it requires multiple professions because it's a mix of between the technical elements and the softer side for the community. A lot of people look at a total flood warning system as just a technical system, but a very key element of that, as Kath was sort of alluding to, is getting out to the community to make sure that messaging gets heard, the communication gets out there, and they understand the warnings. And there's a beautiful match between technology and community when you can make it work right. And that topic will go through a little bit. We'll talk about that a little bit later. As we were saying there, and again we highlighted, often this sort of thing in the community, the warning systems are often the last thing that we think about, unfortunately. They seem to be pushed right to the end. And to be honest, from my perspective, it should be front of mind. Like when we start a flood risk journey, one of our outcomes should be better flood warning, better flood risk understanding in our communities, better communication. We should really be focusing on that first and foremost, because it's a very easy thing to do to get out and talk to the community about their flood risk. And to have the community involved in how those systems established is really important as well, to not just, dictate to a community how it should be, but having them involved about, localizing the elements of it is really important. And end on that in that upcoming course, there's some really significant advancements in this space recently. So pretty excited to show that one. So I won't touch on that one too much.
You just click again for me, Adam. I think this is our last slide, so we're just bringing it kind of all together. Essentially, the aim of the game is shrinking the triangle by reducing the length of each side, but it takes a lot of different approaches and ingredients and players and stakeholders to make that happen. And it's not effective to just shrink one of the sides of the triangle. We've really got to be working on all three in parallel. So I hope that, brings it all together for you. And I think we've got a little bit of time for Q&A, so we've probably gone over slightly.
Oh, that's all right. And again, for those who need to run, you'll get a link to the recording. So what we're going to do is we'll introduce these two courses and let you know what's coming up. But for the panel discussion, we'll stay on for a few minutes for those who can keep joining us, because there have been a ton of questions in the background. A lot of them we can't, even just looking at a few of these, just offhand, the ones that are most upvoted, probably can't even be answered in a few sentences and would require, something like this course coming up. So the answers to a lot of the questions in the chat line will be covered in these courses. So, Kathleen, you want to just kind of introduce us to what you'll be covering in this course that you're leading, along with some other experts in September?
Yep, sure. So the last 3 Thursdays in September, we're going to break down each of those sides of the triangles even further. We're gearing it towards people that work in flood modeling and don't really have an appreciation or understanding of who you're doing a flood modeling for, your end client, whether that's a council person or a developer or someone in floodplain risk management. What are they doing with the outputs of your model to actually shrink those sides of the triangle? So each session is going to be a different one. So the Thursday, the 11th, we'll start with shrinking the hazard using some physical flood mitigation infrastructure. We'll be partnering with a civil designer based in Wagga Wagga, regional New South Wales, who can actually tell you what goes into levee design and what flood modelers, essentially all of these sessions are what floodplain risk managers and end users wish flood modelers knew. So if you know a flood modeler, if you're kind of new to the industry and you don't know why you're modeling something, you're just trying to build the best model you can, this is the perfect course to have a better understanding of what someone's going to do with it, and then you'll do a better model and you might be able to stop modeling a bit earlier because you've already done what they need out of it. So that's what my course is about. Yep.
Perfect. And Adam, let's hear about your course.
As I was saying before, this course will be targeted at multiple types of organizations, community, government, consultants, and I guess it aims to give an overview of total flood warning system. But what it'll also do is focus on the technical aspects of the system. So the flood gauging, the forecasting, the flood intelligence that comes from those systems, and then morph it into disaster management and the community as well, and how those two things mash together and how they come out at the end. So that the components of it will be design based. Our systems are design, but probably some of the most exciting parts of it are you'll get to see inside a system. So a technical flood forecasting system, an intelligence system, how that information gets out to the community, how we provide warnings, how it's actually worked during past flood events. So it'll be led by myself, the technical flood risk manager, but also a local government disaster management professional who's got a lot of experience in managing flood events. And I guess for me, this course is really topical at the moment because it feels like in Australia there's a flood every week at the moment. And I reflect on some of the floods in America recently as well. And it's just a thing that needs to happen, and we need to progress it forward more in our country. It's something we need to do better, and I'm sure internationally as well, we can all learn from each other.
Yeah, and just tremendous, impact right now. And really, when you look at the news, some of the things that get thrown around politically, you can argue one way or another about why, there has been a collective failure to get these early warning systems in place and flood warning systems in place, to save lives. But we as an industry, have had a collective failure in communicating that message. That's part of why we do what we do. That's part of why Adams and Catherine are so passionate about what they do. This does save lives. And if you look at some of these things that have happened recently, there's some in India, some in the US, some here in Australia. People in the chat have put in some things with some fatalities. Some of these could have been prevented if we had these systems in place. So come along, let's learn a little bit more about it. Let's get the message out there that it is worth investing in these systems. And if there's a dam, where you can't afford, it's in an area where they don't have regulations for these early warning systems to be tested and operable. And, and people say, oh, it's too much. It costs too much. If an early warning system is not in your budget, maybe the dam shouldn't be built. Maybe the mine shouldn't be operated and the tailing shouldn't be, we need to have these things in place. So hopefully that message has come across. Yeah. So with that, let's now move into the expert panel discussion. By far the most upvoted question here of the many that have been asked is one that an anonymous attendee posed and says this is a bit spicy. So I'll leave it to both of you to kind of answer this one. So, well, okay, thanks for that. But what power do we have to inform better decision-making when politics overrides science? And then there's a recent example cited where the government decision to try and solve the housing crisis was put out there by developing greenfield land in a flood-prone area. So the risk just gets accepted and then gets passed along to unsuspecting customers. By far, that was the most upvoted question. Comments on this spicy question, as it's called in here. Start with you, Catherine, and then over to Adam.
Okay, yeah, that's a really good question. And as someone who works for local governments where the end decision is left to an elected official rather than a scientific technical official, it can be super frustrating. But I was recently at the ASFPM conference in New Orleans, the American State Floodplain Managers Conference. And this was brought up with how do you get a congressman to care about your flood risk and your floodplain risk management? And what the staffer told us, she was like, I've worked for congressmen and women, and what you need to do is appeal to what are their core job description requirements. And in America, it was national security, economic development, and public safety. And maybe in Australia, we could swap national security for some environmental values. But she was like, if you can connect first on one of those topics and then follow with some data or some science, you've got a way better chance of bringing them along with you for that understanding. And yeah, I suppose like journey to be a bit cliched, but if you come straight back and say that's a floodplain, that's a really bad place to have people, you're not going to get any traction because their main focus in that moment is solving a housing crisis. So flipping the script and trying to not lead with data was the advice from those from that American context that I think we can apply in Australia in our political context as well. And include those decision makers throughout your modelling and assessment process as well, rather than hitting them with the final recommendation without bringing them along.
Okay. I'm going to post a little clip here from Bo Miles, a filmmaker here in Australia who's joined us for a couple of webinars on his Bad River series. And there's a 1-minute snippet in the beginning that's just fabulous where he he's just mentioned, we all need to be communicators. Start with being a communicator and do not communicate with animosity. If you come across with that in the beginning, you're not going to get your message across. And it's interesting that those are the kinds of comments, even though this is a bit of a technical discussion, those are the kind of comments that are getting the most uploads here. How do we get that message across? How do we communicate that? And you've got to start with those commonalities, not just go at it, politically in the very beginning.
I was going to say, Craig, the thing I do a lot of community-based projects now, the softer side, and the thing I've learned over time is just exactly what you've said there. Don't dictate, just listen. Just listen to what people have got to say, and more often than not, once they've been listened, they generally come around. But if you go in with a preset agenda of X, Y, and Z, and to the comment on the politics, I was in local government for 13 years, and I well understand your angst and frustrations in that. Sometimes, best advice I can give is sometimes there's not a lot. There's some big political issues that we don't have control of as technical professionals, but just grind in, like I said, but probably the best way to deal with politics sometimes is to get out to the community and start talking to them. Because if you can get the community, the way that politics works is it works on votes. If you can get the community interested in something like flooding and flood risk, they may vote accordingly at the polls, and then the politicians may get interested. So my best advice, a sneaky way to get through it.
Exactly. Well, we still have 40 unanswered questions here. We've gotten a few of them. I've been typing frantically away at this, and I think we've had some help from Sophia and others in the background. So thank you for that. Some of these questions, what we'll do is the presenters will go back through all of these questions and try to answer what we can succinctly. If we can, we'll post that back up there. So if you go back and watch the YouTube recording, you will see a link to a document that will have as many questions and answers as we can. But some of those answers, in all likelihood, are going to be, join us for these courses. And we'll get to discuss this in more detail, because some of these would be, 12-page responses if we really tried to dive into it. So what we'll do now, maybe just take another minute or two at the end each to just, bring it home, closing remarks, and make a little bit of a plug for that course. Thanks especially to our sponsors today, WMS and Synergy Solutions. We can't do what we do at the Australian Water School without sponsors. And if your organization is interested in sponsoring something going forward, please do let us know. So Catherine, closing remarks, bring it home for us here.
Oh, thanks for coming along, everybody. There is a good table in... No, let's not do any more data. Why don't you just come to the course in September and we can talk more about all of these questions, but we'll answer what we can over the next few weeks. And you'll help me build the content list for those course specs later.
Perfect. Adam, closing remarks as we bring up the screen here, showing, some of the links that you might use to join future courses.
Yeah, look, I'm quite overwhelmed reading through the comments. I'm not surprised though. Talking to the AWS team in CAF about this topic, I knew it would generate a lot of interest. So I really love that there's that many questions on there. There's that much interest. There's a good mix of technical, and I wish Kath and I had a few days to talk through these things. But hopefully in the new courses we can, and we'll do our best to answer some of those questions. We'll get together and answer them as well. But overall, I think what I might end on is flood risk management isn't something new. It's just probably something that's coming to the table a little bit more now, which for me as a professional, is being in space for a long time, is really exciting for me. We're moving beyond the flood modelling part. There was a myth that, the flood, what Kath was saying before, once the flood model's done, that's job done. We're all over. We've done the flood model. We've got our flood extent out. It's not the case. There's a lot more work to do, and there's a lot more value in digging into this more, whether it's from a technical component or a social component. There's a lot of value we can get, a lot of wisdom we can get out of these models and outputs, and use them for the better community good, which is essentially what we're here for.
That's why we're here. So thanks so much to our presenters. Oh, go ahead, Catherine. Sorry.
Well, fair. I was going to post in the chat a link to a lot of your questions will actually be raised and discussed tomorrow in the Floodplain Management Australia quarterly meeting, which you can join online. I've just chucked a link in that you can register and join for free in the afternoon. It's available internationally as well. So even if you're not in Australia, it will probably be
And anyone looking to come to the Gold Coast, I believe next year, there is a conference in the April timeframe. So come along, meet us in person there. The Water School typically has a booth at that conference, and so we're excited to be partnered up with FMA here, a great organization that talks a lot about flood risk. So thanks so much to all the attendees, to our presenters for joining us today. Your attendance at this one does give us a lot of feedback. Just attending this, the questions that have come in through the Q&A line, your participation, your passion for this topic, this interactive panel that we've had here, it shows us that this is a needed topic. So thank you for attending, for letting us know that this is something relevant, something that we do need to hear more of. Come along to these courses, but do let us know as you exit the webinar. There's a poll there. Let us know what you want to see more of. We can specifically tailor additional courses and webinars around this topic or others that you would like to hear more of that are relevant to your career as a water professional. So thanks so much for joining us today. We look forward to your participation next time with the Australian Water School. Bye-bye.